Large Hadron Collider. The largest and most powerful particle collider in the world is called the Large Hadron Collider, LHC. Between 1998 and 2008, it was constructed by the European Organization for Nuclear Research, CERN, with the assistance of more than 10,000 scientists, hundreds of colleges and institutes, and more than 100 nations. It is buried beneath the France-Switzerland border in Geneva in a tunnel that is 27 kilometers, 17 miles, in circumference and as deep as 175 meters, 574 feet. At an energy of 3.5 teraelectronvolts, TeV, per beam, or roughly 4 times the previous world record, the first collisions were accomplished in 2010. It was upgraded to 6.5 TeV per beam, 13 TeV total collision energy, the present world record. It was shut down for 3 years at the end of 2018 to make more upgrades. The speeding particles clash at 4 spots along the collider. Around the crossing points are 7 detectors, each built to detect a different phenomenon. While lead-lead collisions and proton-lead collisions are normally conducted for 1 month each year, the LHC may additionally accelerate beams of heavy ions. The LHC aims to make it possible for physicists to test the predictions of various particle physics theories, including measuring the Higgs boson's properties, looking for the large family of new particles predicted by supersymmetric theories, and tackling other unanswered issues in the field. Hadrons are subatomic composite particles made of quarks that are bound together by the strong force, analogous to the way that atoms and molecules are held together by the electromagnetic force. Hadrons also contain mesons like the pion and kaon, which were found during cosmic ray studies in the late 1940s and early 1950s. Baryons like protons and neutrons are the most well-known hadrons. Hadrons also include mesons like the pion and kaon, which were found during cosmic ray studies in the late 1940s and early 1950s. Baryons, such as protons and neutrons, are examples of known hadrons. A particular kind of particle accelerator called a collider brings 2 opposing particle beams together so that they collide. Colliders are valuable research tools in particle physics because they have a substantially higher center of mass energy than fixed target configurations, although being more difficult to build. The analysis of these collisions byproducts provides solid proof of the subatomic world's structure and the natural principles that govern it. Many of these byproducts are only created by collisions with significant kinetic energy, and they degrade quickly. Since they are difficult or practically impossible to learn in other ways, many of them,